Okay, now I'm recording. I thought I already was recording. Polygons are shaped with many sides. Concave is the shape where it's caved in. And convex is literally everything else that we see. And all we're doing today and this unit are all convex shapes. So just, it seems like a complicated word. It's not that complicated. It's what we use all the time. The other vocab word you need to know is diagonal. You know what a diagonal is, but remember it's between two non-consecutive vertices, so it goes inside of the shape. The confusing part is you can't draw a diagonal in a triangle because if I were to go from one vertex to another, that doesn't go through the shape. That's just like a physical side of the shape. Same thing if I tried to do this vertex. That's another side of the shape. Same thing if I tried these two. There's no diagonals that we can draw. What we're going to do is we are going to explore the sum of interior angles of all of these different shapes in order to come up with a general formula. So just kind of bear with me for a minute while we explore our way through it. And we're using diagonals to do that. So first thing is in a three-sided shape, there's only one triangle. I can't draw a diagonal. I just have one triangle there. What's the sum of all the angles in a triangle? 180. Perfect. 180. Okay, don't forget that because we're going to keep using that. Now we're going to go to a four-sided shape. I don't know off the top of my head what all the angles in a four-sided shape add up to, but if I can break it into triangles, then I can add all those triangles together. So I'm going to my four-sided shape right here. I can draw from one vertex, just pick one point to go from. If I go here, oh, that's a side, that's not good. Oh, but this makes one. And then I can't draw another one. It would just be the other side of the triangle. So I have two triangles that I can make in a four-sided shape. If I can make two triangles, I can know their sum by doing 2 times what? 180. 2 times 180 is going to be 360. For the sake of today, I'm going to do most of the calculations for us. If that's something you struggle with, go back and do all these calculations later. If you're like, there's no way I could mess up plugging something in the calculator, then don't worry about it. Now I'm going to do a five-sided shape. Same idea. Let's see how many triangles we can draw there. Let's say this is my vertice. Oh, that's a side. Okay. Oh, but that makes a triangle. Here's one. Here's another one. And then the next vertice would be, oh, another side. That doesn't help. 3 triangles. So if in a five-sided shape there are 3 triangles, the sum of the interior will be 3 times 180, which is 540. Last one we're going to actually do, and then we're going to have our general form, is a 6-sided shape. How many triangles do you think will be formed? Why do you think that? Follows a pattern. Good. You saw a pattern. We followed it. That's logical thinking. That's what I'm teaching you in geometry. Let's pick this vertex to go from. That's the side, not helpful. Here's a triangle. That's good. Okay, here's another vertex. Here's another one. And then the last one would be another side, so that's not helpful. 1, 2, 3, 4. You guys were right. 4 triangles. So that means I can do 4 times 180 and get the number of angles, or the sum of the interior angles of a 6-sided figure, which is 720. All right, you said that you followed the pattern. What was the pattern? Like compared to number of sides to number of triangles, what happened? 2 more sides than triangles. So if I started with sides, I did what to get number of triangles? What did I do to go from 3 to 1? 4 to 2. Blah, 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 right? So if I told you we have n sides, I don't know how many n is. I have n number of sides. My number of triangles would be n minus 2. And so that means my general formula to find the sum of the interior angles will be n minus 2 times 180. Oh, you guys just developed your own little formula. Give yourself a high five. Thank you, Jane. Awesome. Thank you, guys. All right, if you scroll down into the box, there's a space for us to write this formula. N, I forgot to mention this in my other classes, but N means a lot of things. It means the number of sides, the number of vertices, the number of interior angles, the number of exterior angles. We use n for a lot of things. Again, the sum of the measure of the interior angles is n minus 2 times 180. I would personally put a box around it. I would highlight it. I would star it. I would make some kind of mental note to myself that this is important. We're going to use this in a minute and then for the rest of today and on your homework. Okay. Now, this is the sum. How do I find the measure of one individual angle? Let me go back. Let me explain one word. I use this word regular. Have I used that word before with you guys? Regular? A regular polygon, a regular triangle? No. We know regular to be just like a normal thing, right? In terms of math, regular means that all the sides are congruent and all the angles are congruent. Basically, it's equilateral and equiangular. Now, if you're like, Miss White, the minute I write this down, I'm not going to remember what equiangular or equilateral means. Your notes are for you to use. Don't just write something because I wrote it. Instead, I might write, if I don't know those words, I might say all sides are congruent and all angles are congruent. That to me is a little bit easier to recognize. If that's the case with my regular polygon, let's think of a couple specific examples. I've got a regular triangle down here where all of my sides are congruent and all my angles are congruent. If all my angles are congruent, how much is each individual angle? Why? Exactly. Colin knew that he had to share the angles, the 180 with all three angles equally. So he did 180 divided by 3 and he got 60. What about this four-sided figure? Do you remember what we call a four-sided figure where all the sides are equal and all the angles are equal? What do we call that? We do call it equilateral, equiangular, but what's the specialist one when it's fours? That's a general term. What about when all the sides are equal and all the angles are equal? You're gonna like hate yourself when you hear it. Square. Square. It's such a basic shape, we forget that it's really important and really special. If a square has all the same angles, what are all the angles of a square? 90. The sum of all of my angles in a four-sided shape is 360. We'll start remembering that, but if you didn't remember it, we literally just did it up here a little bit ago. And if I need to split that evenly among four angles, I divide it by 4 and I get 90. I kind of ruined it because I put 90-degree angles there without thinking a minute ago. I thought I could erase it and trick you. I don't know if I tricked you. Probably not. Okay, so what we just did is you knew in a triangle, all of the angles add up to 180, divide by how many I want to split it up evenly between. Same thing with the square. I divide it by how many I have evenly, or the sum, divide by however many I have. So I'm going to do the exact same thing when I write my formula. Everybody with me? Okay, I feel like I'm talking sometimes. Nobody's listening. Okay. So I'm going to write n minus 2 times 180. That's my sum of all the interior angles. And I'm dividing it by how many angles I have, which is n. You can think of it as number of sides, or you can think of it as number of angles, whatever makes you happy. I am also going to square and highlight this because this is an important formula I'm going to keep using as well. Okay, so if I want to know the sum of the interior angles, I do n minus 2 times 180. If I want to do one singular interior angle, I do n minus 2 times 180 divided by n. Before I move on, I want to take a minute and stop saying things like four-sided figure and six-sided figure. Let's make a list of all the names of these polygons. I think we did this back in Unit 1, but let's remind ourselves. I'm just going to put it in this blank space right here. I know you guys, most of you have like a little hole punch, but I'm going to write it right there. Eli? Yep, exactly. You ready to go? I'm going to call out for them. So you guys Just think for 1 second. You know most of them. I am going to label it name of polygon, just in case I go back and I'm like, what was I writing? And I'm going to say like 3, and I write the name, and 4 and 5. So what's a 3-sided shape? Everybody. Triangle. What's a 4-sided shape? Quadrilateral. Rectangle is not wrong, but I want a general shape. We could have also written square or rhombus or kite or trapezoid or something like that. What about 5? What's a 5-sided shape? Pentagon. What about a 6? Hexagon with an X. Everybody with me? 7 is a tricky one. Heptagon. A lot of us do think septagon, though, so it's a very common mistake. A lot of us want to think like it's the months, like September, October, November, December, because October, November, and December all kind of work. But sept does not mean 7. Sept means something else. Hep means 7. Heptagon. What about 8? Octagon. What about 9? Nonagon. What about 10? Decagon. What about 11? This one I always forget about. Does anyone remember 12?
Dodecagon.
Dodecagon. Very good, Ben. The 11 is a hen decagon, so I think, Jane, you were kind of close. Yes, an engon. Okay, yes. I thought you said a hengon, and I was like, oh, you're kind of close. Hen decagon. I'm gonna be very honest with you. I don't remember 11agon. Like, I have to remind myself that when I teach it. Sometimes you just have to take the L. You may not ever remember an 11agon. You may just have to be like, well, whatever. If you know everything else, I do not care if you know 11agon. Hopefully you can figure it out or guess it. If it's a question of knowing hen decagon and nothing else, or not knowing that and knowing everything else, I'd rather you know everything else. Sometimes as a student, you got to decide what's going to fit in your brain. And if hen decagon's not going to make the cut it. Take the L. It's going to be okay. All right, let's do some problems. All right, let's look at this problem. I've got, what shape is this? Pentagon, because it has how many sides? 5. How would I find X if this was like, let's say, a triangle? And set them equal to 180. That's a triangle, right? We want to use not 180 because it's a 5-sided. What am I going to use? Very good. And how'd you get 540? And what do we do on the chart to get 540? Good. We had to do the sum, which is n minus 2 times 180. And so, ooh, I don't know how that happened. N minus 2 is 5 minus 2 times 180, which we decided is 3 times 180, which we know is 540. I love your brainstorming to use your actual paper and not have to solve anything new. But in case we forgot, I did write it right there. But you guys are exactly right. We're going to add them all up and set them equal to 180 or to 540. So 120 plus X plus 56 plus 151 plus, what's that last thing I'm going to write? 90. Very good. You guys cannot be tricked. So when I add all those numbers up, I believe I get 317. And then I believe I minus that from both sides, and I believe I get 123 degrees. Does that look okay to you guys? No, 417. $120. This is going to be embarrassing if I did it wrong all day. Okay, 120 plus 151 would be 271. And then 56 plus 90 should be 1. It is 417, isn't it? Ooh, yikes. Oh, did I get the right answer? It's 540 minus 417. Oh, okay. I had the answer. I didn't have the other part, so I told the other class it equaled 317, so that's embarrassing. But all right, perfect. So you guys fixed me, but the answer is still 123. You guys doing TikTok dances in the back? Mm-hmm. All right, next problem. How do I find x here? Why are they all equal? Very good. And then what should they all equal? What kind of shape is this? Pentagon? And a pentagon, what's the sum of a pentagon? 540. And so what do I need to do to find out what x is? Divided by 5. Very good. 108. I heard that a minute ago, but that's the real answer. I don't know why I wrote that so funky. Good. We didn't have to find the sum a second time because we literally just found it. I've reminded us how to find it on this problem in case we forgot, but we know how to find the sum. Before we move to the next page, look at the very, very bottom. It says, at each vertex, measure of the interior angle plus measure of the exterior angle equals 180. Let's look at what that means. What if I drew like another pentagon like we were just looking at? Okay, I know that's super ugly, but pretend it's not so tragic. An exterior angle comes when you extend one of the sides and then make an angle with one of the sides that's still there and the extended side. So this is an exterior angle. We can call this like Y, and then the interior one is right here. It's on the inside, and we can call that X. I even drew it as a straight line to show you that they are supplementary, so they add to 180. So these two are supplementary. I'm not necessarily going to use this today, but it might be helpful for you to remember it. I'm about to teach you about exterior angles, and those are easier than interior. So you may choose to always do the exterior angle and then use the fact that they're supplementary in order to find the interior one. So like in this case, X plus Y equals 180. Okay, questions, thoughts, concerns? Okay, I've got 2 more formulas to teach you, and then we're going to solve. I want you to scroll all the way to the 3rd page really quick because I'm not going to write on this page. I know some of you might have freaked out when I gave you the 3rd one. You might have been like, why did you give me notes with a staple in it? The reason is this is a Spark Notes page or a reference sheet or a like where all of your formulas, a formula sheet. I couldn't remember what that was called. I like to think of it as a Spark Notes. I'm not filling this in at all. These are your formulas. We just did the interior one, the sum of my interior angles, and we did each interior angle, which is this one right here. What I'm about to do is the exterior angles. So again, we're not using this. This is just for you to use. So if you want to tear it apart so you can look at one at a time, or if you just want to have it open on your desk like this, it's your notes, go for it. All right, so now we're going to do our exterior angles now that I've kind of softball previewed us. The sum of the exterior angles, always, no matter what shape you have, no matter what time it is, no matter what day of the week it is, it's always 360. No matter what. Whether it's a triangle, the sum of the exterior angles is 360. Whether it's a dodecagon, the sum of the exterior angles is 360. Whether it's a 247-agon, the exterior angles always sum to 360. That may be like a trick question later on. I might try and get you. I might be like, oh, what's the sum of the exterior angles of an octagon? You'd say 360. I'd say, what about a pentagon? You'd say 360. I'd say, what about a hendecagon? Maybe don't even remember what that is. Still 360. Always. I cannot drill that home anymore. Now, going with that, we have to think about what's the measure of one individual angle. One individual exterior angle. Well, what's the sum of them? What did I just tell you all the exterior angles sum to? 360, and then we divide by how many there are. So the sum, or sorry, the exterior angle, measure of one singular exterior angle is 360 divided by n. So those are your two exterior angle formulas. One is simply the number 360, and the other one is 360 divided by n. So if you're color coordinating on your other page, I'm going to say the sum of the exterior angles is 360. And I'm going to say each exterior angle is 360 divided by n. All right, we're going to spend about the next 20, 15 minutes left just solving problems. This will help us on our homework. Questions so far? All right, let's look at number A and B together, and I might loosen the reins for the next couple. Everyone good back there? Is it a class question or not a class question? Do you have a question for me for class, or is it outside of class question? I'm not mad. I just, if I need to help you, I need to help you. Okay, great. All right, I've got some exterior angles right here. This and this and this and this and, oh, what's that supposed to be? 90. Why? It's a right angle. How am I going to solve for x? 360. All of the sum of the exterior angles add to 360, so I'm going to add them up, set them equal to 360. All right, 2x plus 2x plus x is 5x. Negative 12 plus 32 is 20. Plus 180 is 110. Minus 110. Five x equals 250, but x equals 50. All right, all we had to do, add them up, set them equal to 360. Always, 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 always with exterior angles. Shall I look at the next one? Yeah. All right. The next one, how do I find just that one exterior angle? They're all. And it's 6. We could do that. 720 divided by 6. We could also do that. Let's do both ways. I don't know what's 72 divided by 6 off the top of your head. Anybody know? 120? Okay, perfect. So Eli, I like what you're thinking. You're like, okay, I got to find the interior angle. The interior angle is 120. How do I find x if I know that its interior angle is 120? So 120 plus whatever the exterior is equal to 180. So the exterior is 60. You can definitely do it that way. Now, Allie, tell me what you did. Yeah. And they equal what? 360. So Allie went with just worrying about the outside. She knew all the exterior angles summed to be 360. She had 6 of them. 360 divided by 6 is going to be 60. You get the same answer whether you do it Eli's way or Allie's way. Sometimes you'll think that one might be easier than the other one. In this case, I probably would have argued Allie's way is easier, but sometimes you want to use the other one. Totally fine. Totally fine. Yep. All right. What I want you to do is we have 15 more minutes. I want you to take like 2 to 3 minutes and decide which formula goes with 1, 2, 3, 4, and 5. I just want you to write the formula for all of them, and then we'll solve. Feel free to ask a neighbor. Feel free to work with somebody close to you. I want you to list the formula. We have a whole Spark Note sheet. Which of these 4 go with those 5 problems? You may. Try and figure out the formula for those.
Whoa. Oh my God. Oh my God. We did push-ups for that on my team. I push-ups. I got you. Get up. I'm going to 45.
Don't say it again, because I will make you do push-ups if you do it again in my class.
Oh,
Some of them are right. Things like ideas. All right, let's go over these. Number one of this example, it asks you to find the sum of the measures of the interior angle. If I forgot, the sum of the measures of the interior angle is this one. N minus 2 times 180. So to find the sum of the interior angles, I have to do N minus 2 times 180 and solve. I'm going to do 20 for my N, so 20 minus 2 times 180. 20 minus 2, excuse me, is 18. Max, seriously? 20 minus 2 is 18. 18 times 180 is going to be 3,240. Again, calculating you guys should be able to do. So if that's something that's troubling for you, feel free to try that outside of class. But what I'm going to do is I'm just going to solve them just so we're not wasting any time. All right. What about B? It's the same formula, but what's my N going to be? 6. Very good. So now I'm going to do 6 minus 2 times 180. So 4 times 180, 720. We just did that a minute ago. I don't expect you to have these memorized. You might find yourself just knowing what some of them are. You might find yourself knowing that 5 sides is 540 and 6 sides is 720, but you don't have to. That's why we have this formula. All right, number 2. This one asks for the measure of each interior angle. I have to find the measure of one single interior angle. I'm going to use that same formula, but I'm going to divide by n because I want to find not the sum. I want to find one single one. So n minus 2 times 180 over n. What's a dodecagon? How many sides is that? 12. Good. N is 12. So I'm going to do 12 minus 2 times 180 over 12. So what a lot of us want to do is cross, and you cannot cross out. Just because you put 12 on top and bottom doesn't mean anything. You have to do 12 minus 2 and then times that by 180. You're welcome to do this by hand, or you're welcome to put in the calculator. When you put in the calculator, I get out 150 degrees. All right, number 3 says the measure of each interior angle of a regular n-gon is 140. Find the number for n, or find the value for n. Which of the first 2 formulas am I going to use again? The second one. Very good. I need to use the second one, but 140 is not my n. I don't have an n. 140 is actually my answer. So I'm going to set it as 140 equals, and I'm going to put my formula equal to that. 140 is not my n. 140 is not my n. I'm going to solve for n. You can solve by cross multiplying. You can put 1 on the bottom and cross multiply, or you can multiply by n on both sides. Either way, you get the same thing as 140n. And I would also take this time to distribute that 180 into your n into your minus 2. So I get 180n minus 360. I'm going to minus by 180 from both 180n from both sides. So I get negative 40n equals negative 360. And I've got a simple dividing by negative 40 to get 9. This is one of the hardest problems on this paper. Just the algebra can sometimes trip us up, but do we understand how we plugged it in? Yeah? Okay, we got 2 more. Any questions on the first 3? Okay. The measure of each exterior angle of a regular n-gon is 10 degrees. What's the sum of all the exterior angles? 360. I don't know n, but I know that the answer, the degree, is 10. I'm going to use this formula. I saw a lot of this on your paper, 360 divided by n, but I'm going to set it equal to 10 because that's what the answer is. We just don't know what n is. So 360 divided by n equals 10. Again, you can cross multiply, and that gives us 10n equals 360. Divide, and I get 36. It's a really big-sided shape. All right, and then number 5. A regular polygon has 15 sides. Find the measure of each exterior angle. What do we think? 360 what? Divided by 15. Thank you for finishing, Allie. 360 is my sum. We should all be able to say that right away. We should all know that immediately. I'm saying it kind of crazy, but you do need it. We have to remember that that to get one exterior angle, we have to divide by how many angles there are. So the whole total is 360. We have to divide that by 15 to get exactly how much each one is. And I believe that is 24. All right, questions. All right, I sped a little bit through this because I was afraid my iPad was going to die, to be honest. But we have 4 minutes. What I'm going to do is I'm going to pass out your homework, and I do suggest you get started on it, or at least try and identify what formulas you need. Do not wait till Wednesday night to do this because it is due on Thursday. A lot of this is practice, 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 practice. Okay, I am going to stop recording, I think.